Hi guys, welcome to Science. It's October 24th, and I hope you enjoyed your nice long weekend. Today we get to talk about weathering. And weathering in Utah is so cool because there are so many great places that show really awesome examples of weathering. Especially if you live in the South, there's all these national parks like Arches and Zions. If you have the opportunity to go, you should. And as a fourth grader, bonus, you get in for free, which is really cool. So there are two types of weathering. There's chemical and physical. And I'm going to let the video explain that a little bit further.
Let's talk about weathering. Weathering is the process in which rocks are changed and broken down. This process occurs in two different ways. Let's look at the first way. So the first type of weathering is called mechanical weathering or physical weathering, and that occurs when rocks are broken down into pieces. Think about cutting up a piece of paper with a pair of scissors, right? All the little pieces that you make, you can tape them back together and you can make the original, piece of paper, right? Just keep that thinking while we talk about this. So all forms of mechanical and physical weathering take place because of special agents. And those agents are responsible for making those changes. So let's take a look at those agents. First one is called ice, or ice wedging. That's the agent that causes rocks to break apart over time because of cycles of freezing and thawing. For example, water will seep into a crack. So just from ordinary rainwater, it fills these small cracks, and during the colder nights or the winter time, that freezes, and the freezing process causes an expansion, and that makes the crack a little bit wider. And this continues to happen over and over again until you have a large crack in the rock. When you look at our streets and sidewalks, it's a noticeable feature to see potholes and cracks like this because we live in a climate that lends itself to this type of activity where there's a lot of freezing and thawing over the course of seasons like our winter and our really cold fall and early spring months. The next three agents, water, wind, and gravity, all perform the same type of weathering. It's a type of weathering called abrasion. And this is where rocks are picked up and rubbed against other rocks. So as water or wind or gravity pick up smaller little pieces of rocks, they actually scrape them against other surfaces. That causes more and more weathering to occur. And our third agent of erosion are plants. And plants grow in all different types of conditions. Probably outside your own home, you've noticed plants growing through cracks in your sidewalk, your driveway, rocks that are in your backyard. Well, when this happens, the roots that make up the plant over time can actually expand and make cracks larger, similar to ice wedging. And this can split rocks. So in the really extreme situations, trees can really do a lot of physical damage to rocks over time because their roots just get stronger and stronger and break apart rocks very slowly. All right, let's move on over to the other type of weathering. It's called chemical weathering. You can see in the background that this rock formation has a lot of holes in it. All right, it didn't form that way. That something happened to it to make those holes. So a chemical weathering event involves chemical reactions that chemically change the rock. So before I gave the example of taking a piece of paper and cutting it into small pieces and then gluing them or taping them back together, this is totally different. This would be like burning paper. Once you burn it, there's no going back. So chemical weathering creates something new. So here's a couple of examples. This is oxidation. And oxidation is rust. Now, rust looks different in different types of rocks because of the minerals that make them up. But no matter what, rusting will weaken the rock because you're making something new, and that leads to faster weathering. One of the most classic examples, this is not a rock, but the Statue of Liberty went through an oxidation process. I mean, this is the way she looks now, but when we got her from France, she was actually like this. She's made of copper, and when copper rusts, it turns the green that you see today. If we were to go back in time, it looks like a penny. That's the way she really looked when we got her. But that's the oxidation process. Some other types of weathering that involve chemicals: acid precipitation. That's responsible for most chemical weathering these days because of pollution. And we say acid precipitation because it's not necessarily rain. It can also be snow. So any water that falls from the sky. So very visible in statues and monuments that we've built out of certain types of rocks, because they're very susceptible to this type of chemical weathering. And acid precipitation, it occurs when acids that are in the air, and there are some natural ways that acids get in the air: forest fires, volcanic eruptions, that puts certain amounts of sulfur and other chemicals in the air that can mix with rainwater or snow. But burning fossil fuels is a surefire way to put acids into the atmosphere, and that will make acid rain. And when it comes down, you and I as human beings would never know it, but as it falls on surfaces like this, it can eat away at them and break them down over time. And it's visible in a lot of parts of the United States, especially where we've built things out of limestone or marble. If some of that water seeps into the ground through infiltration, it may contain weak acids or pick up some acids from being in the ground, and will dissolve certain types of rocks. So now that water is leaking into the groundwater system. It's underground, and it can create things like this. This is a cave system that's filled with formations that are from the process of water with a slightly acidic composition chemically breaking down rock over time. There are some important formations in this cave that you should be aware of. For instance, the features that are growing out of the ground, and that's really what they are. They're leftover rock, but as the rock wore down around them, these are what are left behind. These are called stalagmites. The G is for forming from the ground. And then on the ceiling, we have stalactites. And stalactites are formations that rock is literally dripping. Like pieces of the rock, as the water seeps into it, it's dripping like an icicle, and causing the rock actually to wear away, because of gravity. So it's a feature notable in cave systems because of the types of rocks that make them up. And our last type of chemical weathering example are lichens. And really, lichens are a fungi, all right, like similar to mushrooms and things like that. But any living thing can actually do this. It's just that lichens are specifically designed to do this. They chemically break down rocks over time. They actually will eat away at the rock and break it into smaller and smaller particles. So plants can also do something like this. Some animals, their waste products can also do something like this. Their bodies, when they die, can do something like this. No matter what, it's a chemical breakdown of the rock because of its exposure to the elements in living things. So no matter what type of weathering we're talking about, all weathering processes break rocks into smaller rocks. They take rocks and make them into sediments, and sediments really include this list: boulders, cobbles, pebbles, sand, silt, and clay. That's from biggest to smallest. So let's review. Weathering is a process that changes the characteristics of rocks on Earth's surface. And weathering comes in two forms. Physical weathering or mechanical weathering is when rocks are broken into smaller pieces without changing their chemical composition. And chemical weathering is when rocks are chemically changed into a different substance. So that's it for now, and thanks for watching.
Now that you've seen the two different types of weathering, here are some really fun experiments that you can even try at home about how water weathers the rocks. I think it's pretty amazing that water is so powerful that it can break down rocks. Check these videos out.
I'm surrounded by rocks, and you might not think rocks are really that exciting, but they are. Rocks come in all different shapes and sizes. Some rocks are bigger, and some rocks are smaller. And you may not believe it, but sand is actually a rock. It's a rock. They're really tiny rocks that have been broken down from bigger rocks. So what in the world could be strong enough to break down a rock like this? I can't do it. What can? Believe it or not, it's just plain, ordinary water. Hi, I'm Jared. Welcome to Fun Science Demos. And the big idea today is that water, when it freezes or rains or snows, that water helps break down rocks. So how can water break down a rock? I mean, if I put this rock in this container and cover it with water, how is the water actually going to break down that rock? I could sit here all day. Well, through science we discovered that it actually takes a lot of time and something else. And that something else is freezing. When water freezes, it expands, and nothing can stop it when that water's expanding. For example, take a look at this glass bottle. I filled it with water. Now, if I were to put a cap on this and put it in the freezer, that water would expand and break the bottle into lots of little pieces. It's pretty dangerous, and we don't want to do that. So, we want to come up with a demonstration that's a whole lot safer that you can try. We're going to show you 3 safer ways that shows the power of water to break things and crack things when it freezes. And the simplest way is an egg. Take a normal raw chicken egg. I don't want to hard boil it because I want all that liquid inside to freeze. And what is that liquid inside going to do when it freezes? It expands, it gets bigger. And when it gets bigger, things break and crack. Take a look at this egg. All I did was put it in the freezer. And when I checked it the next day, the shell had cracked and broke. Here's another safer and tastier way to show you the power of water to crack and break things. This, believe it or not, is a water balloon, a yellow water balloon. I filled it with water and then I coated it with a special chocolate syrup that forms a nice chocolatey shell, a hard shell. I put that in the freezer. When that water froze, it expanded, it got bigger, and it cracked that chocolate shell all around it. I tried it with a red water balloon, and guess what? When that water froze, it cracked that chocolate shell all around it. It's pretty simple to do, maybe a little bit messy. You need special chocolate syrup that turns into a hard shell when you put it on, and a water balloon. You're also going to want to have a little container to catch the mess as it sort of drops off and drips off of my balloon. So all I'm going to do is hold this up and let it ooze down to cover my balloon. Spin it. It's okay if I make a mess. And you can see how the chocolate shell covers the balloon. I want to keep smearing it on until the entire balloon is all covered. Now, how do I freeze this thing without making a big mess? Well, I take a toothpick, stick it through the top part of the balloon, and in your freezer there's shelves. You can slide the toothpick up the shelf, spin it, and hang it there until the water inside freezes and breaks your chocolate shell. Our last safe way to show you the power of water to crack and break things is using plaster. It's harder than an eggshell. It's harder than a chocolate shell. It's almost as hard as rock. And we're going to make our own. You're going to need some plastic cups, paper cups, styrofoam cups. It doesn't matter what kind of cup you use. A water balloon. And pretty much I'm going to walk you through how to make this work. So I'm using a red cup. And the problem with this is that if I mix up my plaster and I try to put my water balloon inside and pour the plaster over top, the water balloon will actually want to float on the top. And that's not going to work. So I have to come up with a way to keep the water balloon down inside the cup. That's what I'm going to do right now. All I'm going to do is use a thumbtack to poke a hole right in the center of the cup. And once I get my hole started, I'm going to use my pencil to make the hole bigger. I twist and push, and now I have a decent sized hole. The next trick is how do I get the neck of this balloon through that hole? And that's where a twist tie comes in. There's a little piece of metal, and these are used to just tie together baggies and things like that. And I can actually push this right through the neck of my balloon. Got it through the neck. Twist it a little bit to make sure it holds. And now, scrunch the end. And I'm going to poke it through the end of my cup. Pull it up. The neck of my balloon is now through. Take the twist tie off. And now, this is hard to see because the balloon wants to stretch. The balloon wants to stretch, so I want to make sure it's not coming down all the way. So I'm going to pull this up just a little bit higher. Stretch it down a little more. I can reach up inside and feel easier than I can see. Once I have it where I'm happy with it, I'm going to take a piece of tape. I'm going to tape the bottom. I like to use 2 pieces of tape so the plaster doesn't come out the bottom hole. Now, I have a balloon inside my cup that's not going to come out or float when I pour in the plaster. So now I have to mix up my plaster. To stir it, I'm going to use my popsicle stick. I guess you could use your pencil. And I have a cup of plaster. Now I need to add enough water to make this about as thick as that chocolate syrup we used earlier. If I put too much in, it's going to get too liquidy, too loose. If I put too little in, it's going to be too stiff. So I'm going to do this little by little. I dump it in and I stir. So I have my plaster the way I want it. You can see it's pretty much as loose as that chocolate syrup. Now the fun part. I get to pour it all over my balloon. So I have my cup. What I'm going to do is pour this down in. And I can pour it right on top of my balloon. That'll help center the balloon. Now the next part is pretty important. I'm going to turn this. And what I'm going to do is try to show you. I want to try and keep that balloon centered inside the cup. So I'm going to use my popsicle stick to poke it around and center it in there. If you see your balloon come up to the top, that means you haven't taped it down close enough to the bottom. So the nice thing about plaster is it dries pretty quickly, so you can just use your popsicle stick to hold it down until it dries and holds it, and then let go. It takes a few minutes, maybe even up to an hour for this plaster to get hard enough to take a scissors and cut away the cup. You can see here, well actually I have 2 different blocks. You can see the actual ribs or outlines of my cup that when I peeled it away. So what are these 2 things? Well, this first one, you can see the neck of my balloon peeking out the bottom, and it was right in the center of this block. I stuck the whole thing in the freezer, and look what happened. As that water froze, it expanded and it cracked and broke through this plaster. The water was so strong, it could break through this hard plaster. Well, what about this one? It's not broken at all. It looks like there's a balloon in the center too. Well, I filled this balloon with air instead of water. And the air, it didn't expand when I put it in the freezer. It didn't crack anything. The power of water to break rocks when it freezes. It's amazing to think that plain, ordinary water has the power to crack and break rocks when it freezes. You know, scientists who study rocks are called geologists. If you want to learn more about geology, check out our links in the video description. Science is so cool and so amazing. Thanks for watching.
Well, guys, I hope you enjoyed your journey in exploring what weathering is, and maybe were able to try some of those fun experiments. You're welcome to pass off Unit 5, Lesson 5, and that can count as your exit ticket as well. So thanks for watching this Play Pause It. Have a great day.